Good day, everyone. Our topic for today is about counting rules and probability. Now, counting rules is a way to figure out the number of outcomes in a probability problem, and to know this, it is the product of all events to get the number of outcomes. For example, if you have an event A and another event B, then all the different outcomes for the events are A and B. For example, problem number 1. A fast food restaurant has a meal special of $25 for a drink, sandwich, side item, and dessert. Now the choices are, for the sandwich, we have grilled chicken, old beef patty, veggie burger, and fish fillet. While on the side, regular fries, cheese fries, and potato wedges. On the dessert, we have chocolate chip cookie, apple pie, and chocolate cake. The last one is for the drink. You have Fanta, Dr. Pepper, Coke, Diet Coke, and Sprite. Now the question is how many meal combos are possible? In this problem, it has 4 stages. We have to choose a sandwich, choose a side, choose a dessert, and we have to choose for the drinks. Now, from the choices, there are 4 different types of sandwiches, 3 different types of sides, and 3 different types of desserts. And the last one, we have 5 different types of drinks. So, we need to find the product of all alternatives. Therefore, the number of meal combos possible is equal to 180. How about this next problem? You take a survey with 6 yes or no answers. Now the question is, how many different ways could you complete the survey? To this problem, there are 6 stages. These are questions 1 to 6 with choices in each question, that is yes or no answers. We can now solve for the different ways. All we have to do is to multiply the two answers by 6 stages. Therefore, the total number of possible ways to answer is equal to 128. Okay, let us proceed to problem number 3. A company puts a code on each different product they sell. Now the code is made up of 5 numbers and 3 letters. Now the question is, how many different codes are possible? There are 8 stages, which are from numbers 1 to 5 and letters from 1 to 3. Now we consider 10 possible numbers from 0 to 9 and 26 possible letters, which are from A to Z. So we have 1,757,600,000 possible codes. For problem number 4, you toss 3 dimes, then how many possible outcomes are there? So every dime considers 2 choices. We have head and tail. Now you toss 3 dimes, therefore the result is 8 possible outcomes are made for the 3 dimes. For problem number 5, your school offers 2 English classes, 3 math classes, and 4 history classes. Now you want to take one of each class. How many different ways to organize your schedule? So the events are 2, 3, and 4. Therefore, it can create 24 different ways to organize your schedule. Now for problem number 6, a wedding caterer gives you 4 choices for the main course, 6 starter choices, and 5 options for dessert. Now the question is, how many different meals made up of starter, dinner, and dessert are there. The events are 4 for the starter, 6 for dinner, and 5 for dessert. So the product of these three is equal to 120. Now let us proceed to another example. You take a multiple choice test made up of 5 questions. Now each question has 4 possible answers. Now the question is, how many different ways are there to answer the test, assuming you don't leave a question blank? So the event has 5 questions with 4 possible answers. Now the result of all events is 1024 as the different ways to answer the test. For the last example problem, an online company offering a date night special. Pick one movie from 4 choices, one restaurant from 5 choices, and either flower, no chocolates or wine. How many possible date night options are there? To this problem, the events are 4 choices for the movie, 5 choices for the restaurant, and 3 options, either flowers, chocolates, or wine. So if we multiply all events, the result will be equal to 60 possible options. So those examples represent the product of all events. That's all for today, and thanks for watching.